All right, let's look at a few examples of geometric sequences. So this is 21 on page 10, and the problem gives me a sub 4 is 25 and r is -5. And they want me to write the first 5 terms of the sequence, the explicit rule, and the recursive rule. So in order to do any of that, I need to know what a sub 1 is. So the way we find a sub 1 is by taking the explicit rule for a geometric sequence, which is a sub n equals a sub 1 times r to the n minus 1 power. And I'm going to plug in the information I'm given. So since a sub 4, that means n is 4, is 25, that's what I'm going to plug in for a sub n, and r is -5, I'm going to put 25 here, I'm going to plug -5 here, and I'm going to plug in 4 here. So that's going to give me 25 equals a sub 1 times -5 to the 4 minus 1 power. And then I'm just going to solve for a sub 1. So I'm going to get 25 equals a sub 1, -5 to the third power is -125. And then to solve for a sub 1, all I need to do is divide by -125. And 25 over -125 tells me that a sub 1 is either -0.2 or as a fraction, -1/5. So to answer the question, the first 5 terms are going to start at -1/5 and then use -5 to multiply to get the next terms. So -1/5 times -5 is 1. 1 times -5 is -5. -5 times -5 is 25. And 25 times -5 is -125. So those are the first 5 terms of the sequence. Then the explicit rule is going to be a sub n equals a sub 1, which is -1/5, times r, which is -5 to the n minus 1 power. And then the recursive rule is going to be a sub n equals a sub n minus 1 times r, comma, a sub 1 is -1/5. Then we have problem number 26, which tells us that a sub 5 is 3,888 and a sub 3 is 108. And they want us to write the recursive rule and find the 8th term. So in order to write the recursive rule, I need to know both parameters, r and a sub 1. So to find r, I'm going to make a table. I'm going to start with 3. So the third term is 108. The 5th term is 3,888. So to find r, there's 2 steps. We're first going to divide by what came in front. So I'm going to do 3,888 divided by 108. But because n increased by 2, I have to take the square root. So whatever the index or whatever n increases by is the index of the root. If n had increased by 3, we would have taken the cube root. So 388 divided by 108 is 36, and the square root of 36 is 6. So r is 6. And now to find a sub 1, I'm going to do the same thing that I just did with that last problem. So I'm going to take the explicit rule, and I'm going to pick one of the values to plug in for a sub n, and r we just found is 6. And so I'm going to go 108 equals a sub 1 times 6 to the 3 minus 1 power. And 6 to the second is 36. So a sub 1 is 3. So the recursive rule is going to be a sub n times a sub n minus 1 times r, which is 6, comma, a sub 1 equals 3. But then to find the 8th term, we always have to use the explicit rule. So the explicit rule is a sub 1 times r to the n minus 1, and then I'm going to plug in 8 for n to find the eighth term. And that turns out to be 839,808. So that's the eighth term of our sequence. A lot of eights there.